Yeah, we're live. It is 7:09. A couple minutes late. I was actually just sending off messages. Excuse me. Sending off messages to Matt over at Sloppy and Calvin over at Nivlac. I think if you haven't checked out their channels, I'm sure you guys have all heard of it. You should. I just sent them over stuff. I wanted to send them shirts because I think I remember Matt sending me shirts. And so I want to send him and Jamie out both a shirt. So, so my shirts can be famous on real channels. So how's everybody doing today? I posted up a video on the test covered a lot of different things. Actually, one of the things was the effect of lift. Excuse me, man, was the effect of lift. So I want to talk about this in more detail because the test that we did was just one thing, one or two camshafts, but one test. And so we ran a Truck Norris, the regular Truck Norris cam, which is 550 lift, and then a Truck Norris NSR cam, which is 500 lift. So we got a 50,000 lift change, and it's a common question. I get this a lot. Hey, what happens if I win up 10,000, 20,000, 30, whatever, even 50,000 lift? How much power is it worth? And and you guys know the answer, as always, is it depends. And the reason that it depends is that's not a universal thing. Some combinations will respond to more lift. And so we need to talk about that because there's also, when you take that next step, like, okay, universally, when you add lift, you don't add power. That's not an absolute thing. You could add lift and not change power at all. You can also add lift and change a lot of power, depending on the combination. You could, if you go from 550 to 600 lift or 600 to 650 or whatever, if you change the lift value, you can, under the right circumstances, change power a lot. So between none and a lot, there's a big range in there. And all of that range is possible from nothing to a lot. And it depends on what you're testing it on. And one of the first things for a lot of people, they can understand that. They go, yeah, it would vary based on what you're testing it on. If you take a stock camshaft and it's a stock motor with a stock intake and stock exhaust manifolds and cats and all that, and we put a camshaft in that adds 50,000 lift, you may or may not get a change. In that instance, you might, because a stock camshaft in something, even a stock motor, particularly an LS, because it already has good heads and intake manifold, it wants more camshaft. So if you put just more lift, even in a stock cam, my guess is you might see some power. There are other instances where you won't see anything. Maybe you have a combination that has a 600 lift camshaft in it. You go up to 650, it doesn't do anything. But the first thing that people point to when you're having this discussion with them is where does lift matter? The first thing that they go to, you guys let me know. I'm sure that somebody's already said it probably. It depends on the cylinder head. If the cylinder head keeps flowing, so if you have a combination where you have a 500 lift cam, but the head keeps flowing to 550 lift or even beyond that, you're going to get power gains. Well, in our test, our test literally, we have cylinder heads that flow beyond the lift range that was tested. So when we went up in lift, we're going up in a range where it would definitely benefit. The cylinder head isn't the change in flow in the cam range that we're testing of the cylinder head isn't. I don't think it's the biggest thing. I don't think it's the single biggest factor that determines whether or not we get gains. I think that it's always the motor. So I'll give you an example of what I'm talking about. So I've run the E7TE Ford heads a lot. We've used them. I use them a lot as baseline heads for lots and lots of head tests back when I did the Ford stuff where we tested all the different heads on the 331 and the 347 and the 392 and the 427 and stuff. And particularly on the 392, when we used the stock heads, we made a lot of power with the stock heads. So we made 350 horsepower. It might have even been more than that. I'm going to go look that up now. So I just want to remember so that my scenario will be proper here. Wait a minute here. What's going on? There we go. It's trying to send me somewhere else. Small block Ford. 351, stroker, 427 head test. We don't want that. That's not what we're looking at. Head test, redo. Final stock. Okay, so we did good. We made 387 horsepower with stock heads, stock untouched, unported E7 to E heads. If somebody asked me if I thought that they could make that kind of power out of a 302, I would tell them it would be very, very difficult. The reason is because it doesn't have, we're creating a situation by adding essentially extra draw. So if you were to flow test the head, like we do on a flow bench, it flows a certain amount. Well, if we flow it at a bigger depression, the flow rate could go up. And that's essentially what we're doing. We're sucking on that cylinder head even harder with the bigger motor. And we put a good sized camshaft in it and that kind of thing. And so we have a combination that is in dire need of more airflow. And this same thing happens when we're talking about lift. You could, if the motor wants more airflow and you give it more airflow, and I would argue that this is even the case if we, let's say we have a cylinder head like an LS head, a ported LS head, where the peak flow is at 600 lift. And at 650, it either stabilizes or even if it goes down slightly. If we have that head on a combination that wants more airflow and we go from 600 to 650 lift, I think we see a power gain. Because I don't think it's a function of what the head is doing. I think it's a function of what the rest of the motor wants. If we have high compression, we have lots of camshaft in it, we have enough displacement, we have enough cylinder head that that's not restrictive, and we change the lift in our camshaft and then theoretically improve this, I think that we can see gains. I'm not saying that the head thing isn't also a factor, but everybody points to that. And I've seen lots of cases where even though we have additional head flow, it just doesn't do anything, or it does very, very little. So that's not the deciding factor. And when you get people on the internet, that's what they point to. And unfortunately, the people that don't understand how dynamic this equation is, if they don't understand, they're looking for, advice and information and they're looking for help understanding the internal combustion engine. And they just don't know enough. And then they get somebody that's supposed to be some kind of expert online telling them, yeah, it all has to do with head flow. And then they think that that's gospel. The problem is that it's not. And so, and on the test that I ran in the video that I put up today, we went from the 500 lift Truck Norris NSR cam to a 550 lift Truck Norris cam. And we got 5 or 6 horsepower. It wasn't very much. And Brian tested that back at their place too. And they got the same kind of thing. It wasn't worth a lot. And I would argue that camshaft, it's a good camshaft. It makes pretty decent power, but it's not a 230 or 240 camshaft. It's a 212 camshaft. And so I think if we did the same test, like let's say we made a 220 or 230 degree camshaft that was 500 lift, and then we made something that was 550 lift, I think you probably would see a different result. And then also, I think we'd see a different result if we tested on, if we tested on a 4.8, I think we'd see a different result on a 5.3, and a different result on a 6.0, and a different result on a 4.08 and the 4.16 or whatever. I think you'd see different results. So like I said, it can go from no power to, a good bit of power. And then also depending on how much you're changing it. Are you changing it 5 or 10 thousandths? Like we see a gain in power when we change the lash on a solid roller cam or a solid lifter camshaft. We're changing lift. We're changing duration somewhat when we do that too. But we're definitely changing lift because the lift of the cam is minus the lash. So if we get rid of some of that lash, like it's called tight lashing. So if we tight lash the thing, we can improve power. And not only can we improve power, we can shift power. We did the same thing when we did the push rod length test, where we effectively got rid of some of the aerated oil and made the camshaft trend more toward a solid camshaft, but just with no lash, which makes it even better. We made it, so that it's truer to its designed lift and duration. It's lobe specs. We did by getting rid of some of the aerated oil in the hydraulic lifter, and by taking lash away on a solid one, we're kind of doing the same thing. We're making the cam closer to what the cam specs are, and in doing that, you're like what we did with the push rod test, and what we do with lash too, because we did this with the Duntov cams on the 302 and the 327, and then also even the LT1 camshaft. These all responded to us tightening the lash on these things, but it tends to make the camshaft a bit more aggressive, and so we usually see, loss in low speed power and pick up more power on the top. At least that's what happened when we did these tests. So I don't know if you would see that when we see the gains from the gains that we saw on the test, and this is what I think would kind of happen with this kind of airflow deal, is if you look at the gains that we saw on the Truck Norris cam versus the NSR cam, the gains that we got are primarily at the top. And Brian, same thing. I mean, same kind of deal. And so you got gains mostly at the top. It wasn't gains everywhere. That's another common misconception. People think that if we just take this camshaft, we add a bunch of lift to it, that we're going to pick up power everywhere. It's going to make more low speed power. It's going to do all these magical things. Where is the thing airflow limited? Where does the thing need the airflow? That's why we test, because it's such a weird dynamic equation, and we got to find out all the answers. And then when we find answers, we realize that we only found the answer to one very specific question, and never a universal thing. And then obviously people can talk about the fact that when you're adding lift to it, you're changing the ramp rate and the stability, and there's all kinds of things, and valve spring life and all that. Quite honestly, and I think I talked to Brian about this. I was asking him if he thought that if we reduce the valve lift on the NSR cam, I told him I wanted to see Spintron data on the NSR cam versus the regular Truck Norris, to see if because the ramp rate has to change as you change the lift. And so I want to see if the load profile is more stable because of that. And I don't remember seeing that data if we did. Very simple one. Does valve lift add power to your motor? Very easy, very vague. Purposely so. Tim, single override cam Tony. Eric, what's going on? Willie, Big Willie. Modesto's in the house. I have relatives down that area. Australia's in the house. LCXU. Buffalo, I like that. Told Matt and Calvin to message you. They didn't message me, but I just sent them a message just now. But I think I saw your post. I saw somebody's post about that. It just reminded me that I needed to get them some shirts out. Low duration, high lift helps out with torque development. Would high duration, low lift be bad everywhere? I don't agree with the lift thing. I don't think that that's really a thing. I don't think that that's an absolute. I think maybe it can. My question is, lift more important with boost? Well, if we go by the universal understanding that boost multiplies what's their NA, then I don't think that it does. Although I had a discussion with Brian the other day, and he told me that they've tested a camshaft where one camshaft made more power NA, but didn't do that under boost. So I told him I wanted to see that, and I wanted to see that test, because that would go against. I've never seen that in all the years that I've been testing, and I've never had anybody be able to show me where that's happened. And so I'm interested if there is an exception to that. Just watching your best versus Norris video 2 years ago. Now I got to see the LBT versus the Norris. A low buck truck and a Truck Norris are going to make really, really comparable power, like we saw with the Chupacabra and all that. I don't think you're going to see a difference there. Valve overlap is a question when you're talking about boost. The NA power curve is what I focus on when I'm talking about boost. I don't worry about overlap. I don't worry about any of that stuff. Sloppy loves getting free stuff. Yeah. Indiana's in the house. I have a relative that went to school there. Boost and cams are two separate problems. Cam affects VE, boost affects density. Nitrous helps. Nitrous does help. Throttle plus the bottle. Nitrous also helps with boost. It does. Real man of genius. I miss those commercials. I know. The Interesting Man in the World. All those were good. Those are some good ones, that's for sure. Still in the 1990s, LT1, LT4. That's good. Those are both good. Nothing wrong with those. I like that the LT4 guys think that they give a hard time to the LS1 guys, and as they should. That should be a thing. I remember posting a valve lift thing way back, and I think that this is when I was doing either LS3 heads or LS7 heads, and I made a post that I think we did a test made with rocker ratio or something, and they didn't really gain any power on the combination that we tested it on. And then I made the comment that the more lift didn't help, and then I got a couple of racer guys that wanted to throw down and say, "Are you saying that lift never helps?" I'm like, he's up there, speed shifter. I'm not saying universally. I'm saying on this motor when we tested it that didn't do. Oh, come over here. I'll show you how lift works. And I'm like, look, dude, I'm okay with that. I'm okay with lift working. I'm not. I'm gacking my piston rings for turbo. Do they all need to be the same? They're all between 25 and 30. That's fine. When I did the Big Bang stuff, they were all within 5 or 10 thousandths of each other. Playing with those mobiles and Pontiacs, also cool. You spelled LT5 wrong. The problem is you say LT1 and LT4, and then people have to ask, well, which one is it? And it's not just, it's not just one or two, it's a bunch. Is there an equation of how much boost to bore diameter? There's an equation for ring gap for that. Do you have a good resource for clearances? You want main bearing clearances? All of that stuff's online. What's the life of a mid-cam LS1? Are you asking what the life expectancy is? Like how long will a mild cam LS1 last? If it's tuned properly and you change the oil in it, it should last a really, really long time. Yes, on 90s LT1, LT4s, but also 2000s LSs. Okay. I found small block Chevys like lift. Again, as a universal thing, I don't agree with that. There's going to be lots of small block Chevys that don't. There's going to be some small block Chevys that like it a lot. Then there's going to be small block Chevy combinations that may or may not like it, that are in the middle area. In the SB2, the lash is 18, intake 24 exhausts without. So that's what you're running on your motor for lash on this. Is this a solid roller cam or something? And is that a hot or cold lash that you're talking about? Here's you, Mr. Giant Taco Salad Inventor. That's right. 3800s. Solid roller 658. Sick burn. Throwing out the mama jokes. Your mom's a solid roller. I have to honestly say, I especially back in the day, I heard lots of mama jokes. I have never heard that one. Number 8500. Sorry if I bother you. You don't have to apologize for anything. Just ask a question. It's all good. That's why we're here. That's what a question and answer period's for, man. Would I be able to run 650 carb on an inline six-cylinder without any issues? Yes. Does your inline six-cylinder, whatever it is, does it need that much carburation? Is it making enough power to utilize that? If it not, it might be that the signal will not be great to that carburetor if it's too big. Like if you have an inline six-cylinder that's making 150 horsepower, it probably doesn't need the 650. A 550 probably would be fine, or 500. Ford responded better to duration, next cam timing. Pulls a trick question. Could add power. That's right. It's always a trick question. Hope to see you at SCSN. What is that? Cam lift matters only if you have a combination of other parts that can get the air in. Yes, it adds power. What do you think about a stage 4 Brian Tooley cam for a 6-liter? All right. I think the cam that you picked, or that you're picking for that, is going to be dictated by a number of other things. What else do you have on the 6-liter? What are you trying to achieve? Do you have available piston to valve clearance? What car is it going in? Do you have a converter, gears, yada, yada, yada. Have you run a 285, 293, 621, 624 LS cam? Is that 285, 293 an advertised number? What is the 50 number for that? But the answer is probably yes. But you didn't tell me what the LSA was. I can't hit both yes and no. We know where you're at. No replacement for displacement. It was me. Matt liked my comment, right? This live, probably when you messaged him. Oh, cool. Emmanuel, I run 2 Holley 500s on an inline 6, both 250, 292, and a Ford 300. Worked on all of them. Gary, are those modified ones? What did you do to them? Greetings from the People's Republic of Illinois. Canada. Oh, Canada. Got some stellar Canadians winning gold up there in Paris. Congratulations. How to get 500 torque on your TPI 350. Use thinner rings, circle track, tested Schoenfeld sprint car straight, step and tri-Y on 8.6 to 1, comp 350, tri-Y torque up 20 over others. I've tried tri-Y headers and I've not seen them add the torque the way that people talk about tri-Y headers adding, but I would like to see that. I would like for that to happen. I think thinner rings could help, but I don't think thinner rings are going to help the torque nearly as much as they're going to help the horsepower. But I didn't have anywhere near the camshaft that I should have had in it. And I didn't have the compression. I didn't have a softened chamber. There were a lot of other things that I could have done to make more torque. Did you try a sloppy stage 3? I have tested a sloppy stage 3. Lift is great till the valves hit the stock pistons. Not enough valve reliefs cut in the piston tops. But lift doesn't really do that. Duration does that. Duration is the key element to piston to valve issues. Richard, how's your day been? It's been excellent. I got a lot of stuff done today. I was able to post a video, so that's always good. And now I'm doing a live feed, also good. Got a bunch of cams shipped out today. That's good. CJ, what's going on? Changing oil makes them last longer. I feel like I break the vehicle, I'll take care of. But the beaters last. That's the way junkyard motors are. The ones that we don't care about, they last forever. Is it me, or do the LT1 first gens feel better than an LS1? A first gen LT1, like a 1970 LT1? A 1970 LT1, at least in stock form, compared to a stock LS1, the LS1 makes way more power. Scrolling back. Not a cam question. Doesn't matter. But has anyone had experience with the dormant LS2 intake manifold and boost? Yes. Yeah, we've run boost. I don't remember if we ran 16 pounds on it, but I don't think that would be a problem. The LT1 really is one of the other guys. The Gen 1 LT1, I don't think is. That's just a regular small block. The Gen 2, I think, is. You really need to bump the LT7 to 1,105 horsepower, 201 horsepower per liter. That's good. I'm sure that the minute somebody puts E85 in it, that will happen. The lift helps in the same way that a bigger throttle body helps. As long as the engine keeps wanting more air, it keeps making more power. Yeah, sometimes throttle bodies don't do anything, but they do a lot on like positive displacement supercharged combinations. I built my 76.8 at 455. My ported 71 GTO 66 casting heads, 280 ISKI. Had over 300,000 piston valve clearances. Yeah, a 280 cam is not that big, right? Question is what's considered large and what's considered small. Family Outcast doing a low buck build on a 5.3 LM7, going in an 88 Caprice wagon for towing and traveling. Good for 450 horsepower NA. What's good for heads and cam? Well, for that power level, if you just put cam and springs in a stock motor, like the low buck truck that I have, that would get you 420 to 425 horsepower NA. If you put the bigger truck plus cam in, that would get you right near 450 flywheel horsepower. You're not going to make 450 wheel horsepower. So if that's the number that you're thinking of, that's not going to happen. But 450 flywheel horsepower, definitely a possibility. The camshaft would add 60 to 70 horsepower to that combination. So really, you're only a cam away from that. You don't need to put different heads on it. 680 lift on crossfire heads. Cool thing about small gear, low compression Pontiac iron heads, you have tons of piston valve clearance, even with the high lift cams. Is that because is the valve drop different on that chamber than it is on the others, or is the piston way down the hole? Does that valve release? What's the valve clearance thing? LP4 706 ported heads, truck Norris cam. LS3 intake manifold. Corey, is yours the one that has the adapter with the LS3 intake manifold? Love the Caprice wagons. I do. I like the wagons too. We cheated the Olympics. Lots of shade being thrown at the Chinese swimmers. I'll say that. Are there any guesstimates for how valve lift can affect the cycle life of matching valve springs? Open-ended, I know, but for long life builds, when or do you stop adding lift to prevent valve fatigue? Well, I don't look at just those two things. I never look at any sort of build of valve relief versus valve spring fatigue. If you're adding something that has lots of lift, the more lift that people add, the bigger the cam's going to be, the less likely they are to be thinking about a long life thing. So I don't think about that. I think that a lower lift cam probably would have better valve spring life. Like if you look at the factory stuff, there's lots of sub 500 lift stuff. And then there's also 550 lift stuff. But the OEMs went to the engineering and design level of their cams to make them stable, to make them last a really, really long time. And the same thing with their valve springs. So they made a combination that they knew would last. When you do that with who's ever run-of-the-mill camshaft and springs, that's a hard question. And just the lift and the spring thing is not the only problem. Because if you look at what a spring is doing while it's functioning, just the fact that you're compressing is not the only problem. 230 Chevy, but I already have the carb and the 4-barrel intake and exhaust from the car. I don't want to modify the cam or anything. I'm scared to overcarb. You don't have to worry about overcarbing it. In fact, when you overcarb it, what a lot of people think is, oh, it's just going to drown the motor. It's not. It's actually going to be lean. It's not going to be rich. If I run silicone couplers, can I run 20, 30 pounds of boost on the cold side? Obviously, all of the big bang motors were all silicone couplers and clamps. Usually the kind of T-bolt clamps, but a lot of hose clamps too. And I don't recommend that. There are better ways to do it. We dealt with the hose blowing off mostly because of the hodgepodge combination of tubes and the number of clamps and silicone couplers and stuff. Because I didn't want to make a dedicated tube. I should have, just especially when I was doing Engine Masters, I should have made a dedicated tube so that it would stay there, but it didn't. And we blew the tube off. Although it does make a really cool video when you blow the tube off and it just sprays condensation out everywhere. It looks like the motor blew up, except that it's all coming out of the intercooler. So if you take a low buck truck ground with 0.2 lift, one with 0.4 lift, and one with 0.6 lift, would there be a difference in power? I just showed you that. The video that I put up today showed you what the change in lift does. It went from 500 to 550 lift. I've seen a lot of videos where 1.5 versus 1.6 rockers gained almost no power. Yeah, I have tests that I've done on some small block Chevy things where we didn't gain in power going to... I've done tests where we've just done roller rockers and then where we've done rocker ratio changes. Usually rocker ratio changes, a lot of times you can see power. Sometimes we didn't see any. Have you heard of power blast plates for carbs to help with fuel atomization? And they don't know what you mean by thoughts. Any Marathon 3800 Big Bang news? Nope, I haven't run anything for a while. Ground down my cam to zero lift for maximum valve stability. It's just the heel of the cam all the time. It's all heel. I have a Magnuson 112 on my LQ4, sloppy C3, 799s, dual springs. Using it for burnout competitions. I keep snapping rear blower belt on the 7,000 rev limiter. How high can I rev it? I don't know. Is it... A lot of times the belt letting go on the blower things, are you ever decelling this thing? Or are you throttling back and forth, like loading it and unloading it? Usually that's not an RPM thing unless you have a belt alignment problem. I hear about making power reliable. How long do you think a stock bottom end Gen 3 would live at 600 torque, daily driven on the street on a heavy SUV? I don't have any idea. Having never tried that, it would just be a guess. The thing is, you're not driving around at 600 foot-pounds all the time. In fact, very rarely are you driving around at 600 foot-pounds. 600 foot-pounds would be heavy load under boost. So if you're racing it, accelerating, or if the thing that I would be concerned about is towing it, and I would actually be less concerned about the longevity of the motor than making sure that your tune is correct. That would be a real critical thing. But if you do that, please let me know. And I'm curious about the longevity of that. I can tell you the motor wasn't designed for that. 416. You have a 99 F body 3.8 liter, the supercharger on it. Only snaps belts when I ride the rev limiter. Yeah, that doesn't surprise me. How many miles can an engine last with an LS1? What's a mid cam? 280 megas, 232 at 50 on a Pontiac. Does valve lift add power to your motor? The poll doesn't specify anything about rockers at all. In fact, the question was more about changing a cam, but you can interpret it any way you want. Todd Emmanuel, Todd is telling me he put a 600 vacuum secondary on his friend's Ford inline 6-cylinder. A 300 would be good. With a small cam and Offenhauser intake, it runs great. Jeffrey, you got a 304 AMC? That's awesome. I would love to run an AMC. Flat tappet cam. My break-in stuff happens before we put the motor together. I put assembly lube liberally on the cam lobes and on the bottoms of the lifters. And then we fill it with a high zinc break-in oil. And I usually run an additive. And then we use a drill motor to prime the setup so that we have oil up to every one of the rockers. And then I usually don't just adjust the rockers. If it's a flat like a hydraulic cam, I usually don't adjust them until we have oil pressure. That's one of the last things that we do. And then once we have oil pressure on all of them, only then do we stick the distributor in, set it about where we want it, 20, 30 degrees, and then start it up. And then when we start it up, we run it through a break-in cycle. So we will cycle it from like 2,500 to 3,200 or so, and we'll vary the load. I like to vary it from 30 or 40 to 70 or 80 foot-pounds is the way we're breaking it in. And that's how we're changing the RPM also. When we dial in more load, the RPM comes down. And then when we release the load, the RPM goes back up. But it doesn't ever, the way we have the throttle set, it doesn't ever go any higher than like 3,200. And then we run it through, it cycles that. So we can dial in how long we want it to hold each position, and then how many cycles we want it to go through. And then we program that in and let it go. A lot of times I just do it manually. So I'll hold it there for 5, 6, 8 seconds, whatever, at each load point, and just keep doing it, and you release it and release it. And then we'll let it cool off, because a lot of times that can heat the oil up, doing that kind of loading for that long. So if adding lift to a cam by reducing lash cost low and power, does that indicate the cam is too big? That's a subjective interpretation. Is it too big for what? Did you want more low speed power? Did you want less low speed power? Did you want more top end power? What did you want? So if you don't like the fact that it lost low speed power, then maybe you could put a smaller camshaft in it. If you want a cam that makes more low speed power, you certainly can do that. That would be you. But that has nothing to do with the cam. The cam, like I said, is a wholly subjective thing. Pontiac drag racers have gone back to 280 to 290 at 50, even with twin turbo stuff. If you get them to make lots of power NA, how high are they revving those? And then how big are they? Empty pockets, 212, 218. That's a good street duration split. If your motor makes 400 at the crank, how much power do you lose at the rear wheels? The answer is always, it depends. How much do you lose? What is your drivetrain? How did you test it at the flywheel? Did you test it with accessories on it? Did you test it with full exhaust on it? Did you test it at the same operating temperature that you run in the car? Does it have the full air intake set up the way that it does in the car? And then after you get through all of those things, those basically test differences, then what is your drivetrain? what transmission are you using, what converter are you using, what's the drive shaft length and diameter and weight, what rear end are you using. A big thing is tire size. How big and heavy are your tires and wheels? All of that stuff comes into play when you start calculating the losses of, because it's not a percentage. LS stuff, going from the engine dyno, the way that we run it, to it going in the car, 100 horsepower is a pretty good estimate. $212, $218, or a $218, $224 on a turbo 4.8. Well, what are you trying to do? Empty pockets. What turbo do you have? What gears do you have? Are you trying to drag race it? Is it a street car? Personally, I would go, if it's a street car, I'd go a smaller cam than that probably. Or I'd at least pick a 212 cam. Got my engine hoist today to get the 5.3 out of the truck in my garage. 20%. That's the thing. There's no percentage because, like I said, all of those things that I just said could all be different. And so that's why there's never a strict percentage. My friend Ed had a custom Ford Windsor 363 built for 3,000 horsepower. He installed a Bullet 900 lift cam. 3,000 horsepower would be a lot. Do you have a video that breaks down camshaft basics? An internal combustion engine is pretty basic, but the black magic voodoo comes into play with all the cam technology for us mere mortals. I don't know what it is you're trying to find out about the cams. There's no video that's going to break down camshafts. I mean, I could tell you basically what lift is and what duration is and what lobe separation angle is. And there are videos out there that go over that, and some good ones to learn basically what people are talking about when they're talking about camshafts. But there's not going to be a video out there that teaches you what takes decades to learn with lots and lots of cam testing, because there's even lots of cam guys out there that I know that design camshafts that don't have enough dyno testing to understand camshafts. I'm replacing my dyno testing experience. I'm replacing my 96 Ford truck, 351 Windsor with a crate motor. It's completely stock. Is there a cam I could swap out that would give a little more torque without changing? I don't know what crate motor you're putting in there. I mean, I don't know what crate motor you're putting in there. I also don't know what camshaft you have in there. So it'd be hard for me to suggest another cam without knowing what the cam that's in there is. Steve Morris calls water condensation water explosion. It comes out violently when the line breaks off. I think that the hose coming off is in that video, that Engine Masters video. I have a copy of it. Ed took the 900 lift Bullet cam out, went to a 750 lift cam. Wants to drive 3,000 horsepower, not changing valve springs every Monday. That sort of level stuff, that kind of lift stuff, I think it's got to be hard on springs. I've heard that there are lots of drag race things that might be, one or even just a handful of passes before they change them. Does lift change power? Edward, were you here at the beginning of all this? Running a Summit Stage 4 on my 6.2, FR230s, 3500 converter, and 410s. Should I put a tighter LSA cam in for better mid? Is it not doing what you want it to do right now? What intake manifold do you have? And do you have a stock bottom end where you're not concerned about piston to valve clearance? Do you care about idle? family. I don't remember what your combination was. Oh, a 5.3. Flat top pistons will help make more power than the dish pistons. If you have a 5.3 that came with dish pistons like an LM7 and you put flat tops like the 4.8 or like the L33, that will definitely help power. The camshaft is going to, every camshaft, any camshaft that you'd have is going to respond to that change in piston. It's not going to affect piston to valve clearance at all, because where the valve hits on an LS, it hits on the edge of where the, above where the dish is anyway in the piston. So your piston to valve clearance is going to be the same for those two things. Emmanuel, yeah, it may, if the carburetor is too big and you nail the throttle in it, it will bog, but not because it's rich. It's going to bog because it's lean, because you opened up this big air door and there isn't enough air demand in the motor to draw the fuel through, because the carburetor supplies fuel based on the airflow demand. And if the motor isn't drawing air in, it's also not drawing fuel in. So the only thing that happens is nothing happens. It doesn't make any power. It doesn't respond. Need to make the ultimate LS Tech video and trying to see how much horsepower all the LS 536062 can run with forged internals and boosted. No, I don't really, because you just get to the limit of the stock block. And all of the aluminum motors, with the exception of the 5.3, are not going to be good choices for that. The iron motors are okay, but you can make more power than the motor can handle it, especially if you put forged internals in it. The forged internals aren't the limitation now. The stock block would be the limitation. The MP112 belts are discontinued. I've got 5 belts on the way, 2 different types. The rev limiter on a 20 RPM split. The only solution I see is raising the limiter. You can try that. Can you not be on the limiter when you're doing the burnout? Armstrong, I think I answered that question already in the comment that you made on the video. How much worse is the towing application with a truck Norris can be than the stock cam in fuel mileage? I don't know. I've never seen a direct cruise fuel mileage, especially in towing. I don't know what the result of that would be, because I don't know how you would test that. I don't know what test cycle you're talking about, because in towing, first of all, to do an actual fuel mileage test is very, very difficult. To do a regimented test, everything has to be the same except for the camshaft. So that means a big change in tune and stuff. And to be able to drive down the road with everything being the same, the temperature and the grades and all that. So it's very, very difficult to do. And towing makes it even worse, because now the throttle angle changes are going to be more dramatic because you have a bunch of weight behind you. So in a steady state cruise situation while towing, I don't know which one of those would be worse. I don't know. My guess is the stock cam would get the best mileage, but that's nothing more than a guess. Manual, if your car was a vacuum secondary, it'll definitely be fine. If it's a double pumper, it'll be tougher to tune. That's a good point. The secondaries might not open up if you don't have enough draw. And when they do, it's because you have enough draw. 303, so 9,000 RPM from a Pontiac 303. So is this like the 9,000 RPM DZ302 stuff that people were talking about? That seems far-fetched to me. But I don't know because I wasn't there. Is there a cam that doesn't suffer so much below 3,000 than stock, but is okay to 8,000? No, you won't have a camshaft that makes more power or as much power as the stock cam below 3,000 and then also makes power up at 8,000. That cam doesn't exist. There's lots of good camshafts out there. How about Howard cams? I've only run a couple of cams from Howard. They all work. And if they have the specs like other cams, they should do exactly that. I don't think a manufacturer is good or bad, at least universally. I don't think that that's the case. It's a vacuum manual, so it is a vacuum secondary. It's an AVS 650. Okay, I think you should be fine. You tested Doug's tri-wise on 350 and lost power and torque. Doug's have really short primaries. Schoenfelds are really long primaries. Never seen Doug's make more power. I would like to do more tri-wide testing. The problem is that I don't want to do a custom tri-wide test. I want to do tri-wide stuff that people would actually put in their cars because that's what's available. Because again, like I said, a lot of people think universally that, oh yeah, tri-wides add torque. But we know that the universal stuff very rarely happens all the time. It's hard to believe the cam designer was thinking about daily driving 100,000 miles when they made stage 3 and 4 cams. No aftermarket manufacturer is thinking about that. And I would also like to see, Bill, that this is an interesting thing as a side note to what you said. I would also like to see the number of cars where people have put stage 3 or 4 cams in that then drove them 100,000 miles before they broke something or got rid of the car, changed it to a turbo thing, whatever the deal is. I would like to see some, because I get that kind of question a lot. Well, will this, how long will this last? Because what they want is they want all the power, but they want all the reliability of the stock thing. Well, you're not going to get that because whatever the thing is you're changing wasn't part of all the research and the millions of dollars that they spend on research and design to make the factory thing so good at what the factory thing does. When you change that, you've changed it. And so you don't get that anymore. And when you get the extra 60 or 70 or 80 horsepower, whatever it is, you don't get that other stuff. But that being said, like I said, I don't remember talking to somebody that put a stage 4 cam in there and then went on to drive it for 100,000 miles. And like, yes, she's trouble-free, work fantastic. I don't know that we ever get that information because I'm not sure that ever happens. 225, 236 cam. Is this a good cam for an LS1? Yeah. Are you trying to achieve what a cam that size is going to achieve? If you want more low-speed power, I would pick a smaller cam. If you want more high-speed power, you can pick a bigger cam. But that cam will work. Armstrong, I don't know the answer to any of your towing questions. There's no way for me to know that because my dyno doesn't tell me any of that information. They made 480 horsepower of a 303 Ram or 4 tunnel port head, failed connecting rods. Howard's cams are good. Okay, I haven't used those. Well, Armstrong, whatever the camshaft that makes more power at, I don't remember what your RPM thing was, but whatever camshaft makes the most power at whatever our start RPM you're thinking that you want to spool the turbo at is probably going to spool the turbo better. 473 to 74 Pontiac wanted to go racing. SD455 program. Armstrong, you need to back up. You need to tell me how much power you're trying to make. Because if you want a turbo to spool up fast, a GT45 on a 5.3 on low boost with a stock camshaft or a truck Norris camshaft is not the turbo I would pick. If you're running 6 or 7 pounds of boost and you want the turbo to spool up, you should stop talking about camshafts and you should start talking about the turbo, because you have too big of a turbo on there. If you're not trying to make 700 horsepower, you need to pick a 600 horsepower turbo or a 500 horsepower turbo and get it to spool up because it's properly sized for what you're trying to do. And don't worry about the camshaft as much. I like lower lift for engines designed to be on the rev limiter. I know you hate it, but 50% of the people buy a cam for the sound. I agree. And honestly, the number might be higher than that. It's not what I do. Although I like the way cams sound. But I think it might be higher than that. A bit of video on cam idle sounds. If you look at the clips that people have on Instagram and Facebook and that kind of stuff, idle clips are very, very popular. Is it possible to get $1,500 horsepower? Is it supposed to be just 1,500 horsepower out of a twin turbo motor using factory LS3 heads? Yeah, those heads support enough power, but the 1,500 horsepower is going to be at the limit of a lot of things. Like you're not going to want to do it with a factory LS3 block, that's for sure. Stage 3 cams turn into stage 2 cams at 100,000 miles. Does it just wear them down to stage 2s? Barnett, you did ask that question before. If you want to combine a lower RPM cam with a short runner intake, would the curve be more flat and better average power? Then what? Then if you take a high RPM in, or you want a long runner intake and a bigger cam, and then you want a smaller cam and a short runner intake. I think it's going to depend on exactly which pieces that you pick, I would guess. I don't think there's a universal, well, one of those is definitely going to be better than the other. I think it's going to be dictated by what cam we choose and what intake we pair that with, and then what we compared the other combination to. More power equals more wear and tear, more lift equals more valve train stress. What's the longest you've seen an aftermarket cam last? I don't know, because I'm not in touch with people that put camshafts in and then go. I don't see them 10 years later or 20 years later. I know that my crane cam lasted. It lasted 60 or 70,000 miles, probably closer to 70,000 miles. .303 Ram Air 5, Ram Air 4, 303 also built. Cool. Eric, I have hundreds of thousands of miles towing cams and blueprinted motors. Armstrong, I don't know the answer to your question. I have never run that test. I've never run those two cams, I don't think, down at 2,300 or whatever your question is. What LT1 cam size is good if you don't want to retune the computer? OBD1 tuning is obsolete. I don't know how much cam you can get away with and have it still work without a tune. And I think that I've answered the turbo question already. You need a different turbo. If you're so concerned about spool up, you need a smaller turbo. Do you think a stage 3.6 puck LS1 clutch? I don't know what clutch that is. I don't know what manufacturer that is, and we don't test clutches on the dyno, so I'm not sure. Get tuner cap for OBD1. Richard, have you ever tested a Crowder 15511 camshaft? What? I don't know Crowder cam part numbers, so if you tell me what that is. I haven't tested a lot of Crowder cams. I've tested a couple, and I tested a couple of 2-valve Crowder cams back in the day. I'm going to go look up for Mr. Armstrong. I'm going to go look up and see how low we ran these tests. Because he wants something specific. I'm guessing because he wants to go online and talk to people about it, but we'll do it anyway for him. Let's see here. Not that one. These might be that low. Let's see. Cam run 1 and 2. Let's see. Okay, so these were run down at 2,000 RPM. So let's see. Because when people... I don't think that this has that one, though. Nope, that's not there. I'm still looking, still trying to find the answer for your question. I might be able to extrapolate this. Let's see. Okay, that's there. I think I might have found your answer. I'm almost there. I'm very close. We've got some down 2,000 RPM runs. According to the data supplied to me by the guys at Brian Tooley Racing, when they did the test, they loaded it down at 2,000 RPM on their dyno because they have a power mark. The crossover point for the stock cam and the Truck Norris cam was 2,100 RPM. Everywhere else, the Truck Norris cam made as much or more power than the stock cam. So looking at that, the Truck Norris cam would spool the turbo better if you were above 2,100 RPM. So I hope that helps. And you also have too big of a turbo. Is there a benefit to running a mild lift camshaft with VVT setup versus not? When you can swing the turbo, that's beneficial. That's what VVT does. I don't know what your question is specifically about lift. The problem with VVT stuff is that you're going to be able to limit how far you can swing it when you change cam timing. Primarily duration, not lift. Because when you're at maximum lift, the piston's way down in the hole anyways. That's usually not an issue. Although if you're swinging the cam that much, you'd be more apt to get into an interference problem like that, depending on how you're swinging it. I had a builder spec a cam for a 5.3, 226, 234, 113. It almost sounds like a stage 2 turbo cam. Is an XE288 too big to run with an RPM air gap? No, it's a little on. It's a good size cam, but on a 393 it should be okay. I don't know if it's the one that I would pick for a daily driver. Matt, I don't know what the specs are on that cam. Scrolling back, scrolling. And I had I had a lot of comments while I was data mining. I built a 403 Olds, a 260 custom cam, lasted 200,000 street miles. See, there you go. There's a high mileage dude. This is my old 78 Buick Electra. New to the LS world, but is a 5.3 iron block considered Gen 3? They have both. They have Gen 3 and Gen 4 5.3 iron blocks. I used a Magnum 292 way back. It barely lasted 10,000 miles. CJ, you have to find the world's best belt. Yeah, I've never tested that. I haven't bought a shelf cam in 20 years. You're a custom grind dude. Richard has made it to where if you have an LS-based engine, you can figure out what you need without knowing much of anything. Would you put a GT35 turbo on a 5.3 for towing if you're never going over 4,500? Yes, I think that's a good idea. Like I said, that's why I was asking what your power level, your desired power level is. I don't know what you're doing. I don't know what you just mean by towing. You'd have to tell me, okay, all I want is to do is 7 pounds. Okay, 7 pounds on a GT35 on the stock 5.3 is going to be well within the comfort range of a GT35. In fact, it's going to be way in that. It's going to be a way better choice than a GT45. 278, 282. You're running 1.7 rockers. Okay. That's a fairly low lift cam. We should do a big bang on a 318. I am going to do a turbo on the Magnum, but not on the LA one. Not sure how relevant 2,000 to 2,500 under load would be since he should be in a different gear. I go down that road quite often, the irrelevance of wide open throttle at 2,000 RPM, because that doesn't happen. It doesn't even happen in towing. That's actually not a real thing. But I try to give the people what they want. People get fixated on one thing and they want that no matter how much well, this is how people are. No matter how much you tell them that you need to think about this a different way, you can try doing that with talking to somebody about religion or politics or whatever. It's just, it doesn't work. David, yeah, if you look at the tri-wise that they do for like cup motors, and if Dan was here, I'm sure he could chime in there. They're pretty impressive, but I'm sure they have to be $5,000 or $10,000 header setups, though. Gary, you have a 422 cam and a 496. I don't know what that 422 cam is. I don't know what the specs are on it. Suburban, Muncie. Is the Muncie going to hold up to a 496 stroker? I don't know how strong they are. $7,000 RPM, 500 horsepower. It should live a really, really long time. We have 500 dyno poles on the motor that already had 200,000 miles on it at that power level or over. So I think you'll be fine. A 500 horsepower 6-liter is going to be faster than a 500 horsepower 5.3. Because a 500 horsepower 6-liter is just going to be a cam 6-liter. What's the max horsepower you push an L33 block? I don't know. You ask Capizzi, one of those guys, what they've done with it. Those blocks will go to 1,500, and if I was drag racing it, you could go try that. But remember, that's a stock block, and it's not a 1,500 horsepower block. If you're going drag racing and you want to go drag racing and you want to make lots of power, you can't expect that motor won't break, because it's especially at 1,500, because things start to move around a lot. Barrett and Paula. Yeah, no, I get what you're talking about. You want a low RPM cam and a short runner intake manifold, and then you want a truck intake manifold with a 231 cam or something like that. And I get it. But again, that specific combination of a truck Norris cam, and if you picked a Holley high ram versus picking a Holley low ram or a Trinity or a different cam, see what I'm saying? That you don't want an answer to a universal thing like small cam and high RPM intake manifold, and then a long runner intake manifold and a wilder cam. You don't want that answer. Or I can't give you that answer. The only way we can give you an answer would be to test the 4 things that you want to test. And then we could go, well, in this instance, this is what happened. Danny, what's going on? I have a GT35 on my 4.6. That should be good. Question with 2100 RPM crossover point then becomes, would the stock cam still pull the turbo quicker because of the area below 2100? Again, it would depend on what you're doing. Are you just nailing the throttle like at 2000 RPM or something? And also, because one did that at wide open throttle, one cam did that at wide open throttle, does that really translate to spool better? People go wide open throttle off idle all the time. So why not test it that way? So when are they doing that? When are they doing that in a tow vehicle? And how is it not changing down a gear so you have more RPM? Are you talking about they're doing it from a drag race start in a low gear with a stall converter? It's not wide open throttle. It's maintaining cruising. Okay, well, I think you're worried about the wrong thing. I think that when you're cruising and you're loaded with a trailer behind you, you're not going to have to worry about boost response if you size your turbo correctly. They're really cheap, 100% USA lifters way back. Doubtful. Comp cams, 260 cam lifters today lasted 200,000 miles. That might be the case. I don't know what's going on with build quality or metallurgy or any of that stuff. It's been hilarious watching all my 4.8 and 5.3 turbo friends go to a 6-liter in their burnout cars. If you guys remember the 6-liter Big Bang that I did, everybody told me that it's going to break. Oh, 5.3s, you got to have the 6.0 is going to break. It doesn't have enough room between the cylinders. It's going to blow head gaskets. It's not going to work. Everybody said that. All of the knowledgeable people told me that it's not going to work. I said, I'm not an expert. I said, but here's what I think is going to happen. It's going to make more power, more NA power, and then it's going to make more power at every pound of boost. And that's exactly what happened. I didn't know how high we would get, but we got pretty high. High mileage LS53, new timing chain with a cam swap or run it. All of our Big Bang motors, we just ran what was there. I'd put a G30 on my 4.6 if I had $1,800 for a turbo. Yeah, if you get a really good turbo, then you have more range with it, like a real Garrett turbo. Do you think you or Brule has done more dyno testing? I think Brule, since he worked there and he did it almost every day, he's probably done more dyno testing. But he doesn't do what I do. He most of the time, 90+% of the time, what he did was somebody would bring a motor in and he would do the dyno testing and do, they would do lash loops and they do carb adjustments and they do the things that they were doing to run a motor. And that's not what I did. I very rarely did I ever put a motor up there and run it like that, just run a motor. I almost never did that. When I do testing, I put something up there and do that, and then that's the baseline. And then now it's changed a whole bunch of things. Steve did that stuff with Steve didn't do that on his own. I mean, they did some stuff because people commissioned them to do that. But that wasn't his job there. He didn't do that. He did a bunch of that with Engine Masters. But like I said, mostly his job was to run motors on the dyno. But he has a lot more dyno experience. He's a way better dyno guy than I am. He knows way more about the dyno than I do. My favorite was a 4.8 turbo to the 6-liter turbo swap. My friend's Cuddy and injector duty cycle 350%. I think that's too much, right? Have a 85 Buick Regal, cool. Junkyard 5.3 Gen 3 fuel injected truck Norris stage 1 4L60E. I want a fast intake. I want a fast takeoff daily driver. So do you have gears in that, or is that what you're trying to get with? Do you have a converter in this thing? Do you have gears in it? All that would help, or a 50 shot of nitrous would help. Need a t-shirt option. This should be my first mod to the new $500 inline 6 F-150. What year is that? Would you ever be interested in his old job? No. Sloppy crowd gets real emotional about the 7875 being the only LS. Yeah, Matt promotes that a lot, and he's him and Byron are good buddies, and they've done a lot of stuff together. The 78, I think I've done testing on the 7875. I have a Gen 2 version, and it's worked good, and that will definitely make a lot more power than a GT45 will. Matt doesn't like the GT45 for some reason. Engine deck is not flat. I'm trying to develop an LS sprint car combo. 500 horsepower in E85 is going to be fine. And on that note, it is time to go. We're going to end our poll at 86%. Yes, of course, it makes a difference. Yeah, if he has a 241 gear, that's going to stop the thing from accelerating. We'll see you all tomorrow.